start with the question number 1 first. Okay, so question number 1, which one of the following graph represent Gay-Lussac law? So Gay-Lussac apa quantity yang constant?
V.
Volume.
Okay, yes. V constant. So kalau dalam exam kamu terlupa, you can try to do it like this lah. So kalau V constant, kita ada equation PV equals to nRT. So bring constant to one side, then I'll have something like this. So if I were to plot P against T, Y and X, then I have a straight line. And then my gradient would be NR over V. So the answer would be apa ni? Boy, ya kan?
B.
Okay, good. Okay, next question. Which of the following statement is not true of the kinetic theory of gases? The pressure of the gas depends on the average value of the square of the speed of the molecules. The pressure of the gas. Okay, ini ada equation yang VRMS tu. Okay, this one is correct. Okay, the temperature of the gas is proportional to the average kinetic energy. Okay, correct as well. To be exact, I think it's square root T. But okay, for a gas of diatomic molecules, the average translational kinetic energy per molecule is 5 over 2 kT. Betul ke salah? This one.
Salah.
Right. So KTR sepatutnya berapa?
3/2.
Yes, it should always be 3 over 2 kT. Very good. So the answer would be C. Each degree of freedom is associated with an amount of energy given by half kT. That one is correct as well. Okay, yang saya sebenarnya cakap lah. Setiap satu degree of freedom tu represent half kT. So kalau ada 5, 5 over 2 kT. Okay, question number 3. On which factor does the average kinetic energy of gas molecule depends? Apakah yang affect the average kinetic energy?
Temperature.
Yes, temperature. Good. Question number 4. A sample of perfect gas occupies a volume V at a pressure P and absolute temperature T. The mass of each molecule is M. Which of the following expression gives the numbers of molecules in the sample? So kalau dia kata dia adalah perfect gas, maksudnya dia obey the ideal gas equation lah. So you can either use PV equals to nRT, or alternatively you can use PV equals to NKT. Dua-dua dia benda sama, dia just derive daripada yang satu lah. Yang asalnya is PV equals to nRT, yang NKT tu sama je. So since dia kata numbers of molecule symbol dia apa?
N besar.
Yes, N besar, very good. So if I want to find my N besar, so obviously I have to use the second equation lah. So I just have to rearrange this one. So I can rewrite this one as N equals to PV over KT. So the answer would be donkey. And then question number 5, the mean translational kinetic energy of a perfect gas molecules at the temperature T is, jadi kita dah bincang kan, the answer would be C lah. That one comes straight from the formula. Okay, so far any question for the objective?
No, sir.
No, sir.
Okay, I think this one okay kot, no masalah. Okay, moving on to the next one, which is question number 6. Okay, question number 6A, dia kata a fixed mass of an ideal gas is at a pressure P. Okay, mass is fixed, pressure is P. What will be the new pressure of the gas if its temperature is half and volume is double? Okay, so this one maybe you have to take out the information first lah. So it has an initial and final, macam initial and final condition. So normally in this chapter we use condition 1 and condition 2 lah. Okay, sebab sometimes dia ada 3 condition or more. So kalau initial final je kadang-kadang ada lebih, so kamu buat confuse. Kalau 1, 2, lebih kamu letak ya 3, 4 and so on. Okay, dia kata pressure dia P, mass fixed. What will be the new pressure of the gas? Okay, so dikasih P dia, yang asalnya adalah P. So initially P1 is equals to, let's say I put P. Soalan ni nak cari P2. What will happen when the temperature is half? Katakan T1 is T, then my T2 would be half T. And the volume is double. So kalau V1 is V, then V2 is capital 2V. So the question want to find the pressure. So maybe you can use PV equals to nRT per equation. Okay, so from this formula, you can relate with, you can substitute all the values there. And so katakan for P1, then I would have to substitute V1 in T1. So my equation now becomes PV equals to nRT. Dan memang nampak macam tak berubah. Sebenarnya saya cuma nak satukan dia punya equation itu, penyebut dia tu. Dan yang equation yang kedua, it will be P2 V2 equals to nRT2. So here will be P2 yang kita nak cari lah. Let's say P2 is P2. And then we have V is 2V and R half T. Okay, so now you can either, ada banyak cara ini salah satu cara lah. So macam mana saya nak hilangkan N dengan R tu? Yang lain-lain tu macam saya nak hilangkan. Apa cara paling senang saya nak hilangkan penyebut semua tu? Who can give me an idea daripada dua equation ni? Saya patut buat operasi apa? Arif? Ada?
Ada, sir.
Kamu rasa kita patut buat apa?
Ubah gantian.
Okay, nanti boleh. Okay, so kamu boleh masukkan dalam dia. Nanti dia potong juga, boleh juga. Ataupun sebenarnya dia ada banyak cara ya. So cara kalau saya ni macam dah tertumpu sikit kat satu solution tu. We can put equation 2 divided by equation 1. Then I will have P2 2V, okay, divided by PV. So I have N. I have to be careful so that I don't mix things up. Okay, so now I can cancel out lots of things. Okay, and then I left with P2 equals to half N. Then ada yang 2 tu. So 2 bring to the other side becomes quarter. And then P2 saya berguna naik. And then I got this one. Okay, so my P2 is equals to quarter P. So the initial compared to the initial P is actually quarter. Okay, faham ke tak?
Faham, sir.
Okay, so I think cara orang lain boleh buat cara lain. Nah, kamu ada buat cara lain ke daripada saya? Maybe ada cara lagi senang. Ada tak? Okay, saya assume maybe tak ada. Kamu dapat ke tak jawapan?
Baru dapat.
Oh, baru dapat. Okay, it's okay. Okay, now for question B.
Sir.
Okay, it's okay. So before this tak dapat lah. Dia kalau tak ada numbers tu memang problem sikit. So I would expect your final to be something like this lah. It's more like, and then they can give you multiple choice punya answer, like half P ke apa ke kan, P ke, and then it is much easier to make multiple choice punya question, something like this. Tapi working tu panjang kan, bukan pendek. So nantilah esok lah kita bincang format untuk exam. Okay, question number 6B. So A kita dah buat. The pressure of a gas in a container of volume 300 cube is 1.6 times 10 to the power of 6. This one to the power of 6. Mungkin dia typo di situ. Okay, if the temperature of the gas is 100 Celsius, calculate the numbers of molecules in the gas. Okay, first of all, kena buat apa? Umi, mula kita kena buat apa? Biar kita dapat soalan.
Keluarkan data betul.
Apa dia?
Keluarkan maklumat dia.
Yes, keluarkan maklumat dia semua. Okay, itu benda pertama yang kita akan buat lah. So, dia kata dekat sini, the pressure of a gas in a container volume 300 cube. Okay, that one is your V. 300 centimeter cube. Pressure dia adalah 1.6 times 10 to the power of 6. Let's say kamu jumpa dalam soalan, ayat dia macam confusing. You just have to look at the unit. Okay, kalau Pascal tu for sure it is a pressure lah. If the temperature of the gas is 100 Celsius, so 3 equals to 100 Celsius, calculate the numbers of molecules in the gas. So kamu nak pakai formula apa? Number of molecules. Kamu nak pakai PV equals to
PV sama dengan NKT.
Okay.
PV and KT.
Okay, good, very good. So this kind of question straight away you know is either PV equals to nRT ataupun PV equals to NKT. And since the question want to find numbers of molecules, straight away you can use the second question, equation. Kalau kamu pakai equation pertama, you can find the n first, and then once you found the n, you can calculate the numbers of molecules. Sama je, dua boleh tapi extra step lah. So I'm going to cancel that one. I'm going to use the second one. But before that, for any equation that has a constant, you have to use SI unit. Okay, so basically you have to convert the volume dengan temperature tu. Temperature senang lah, you just have to add with the 273.15, then you have a Kelvin. Okay, the volume. Okay, sepatutnya volume ni berapa ni? 300 times 10 negative berapa?
Negatif 2.
6.
Okay,
Lah.
kan? Okay, so kalau dia daripada sentimeter ke meter, dia negatif 2, betul. Tapi sebab dia ada kuasa 3, you have to multiply by 3 lah, which is negative 6. Okay, very good. Kalau dia square, darab 2. Kalau cube, darab 3. Okay, and then you just have to solve using the equation. Then n equals to PV over KT. So my P is 1.6 times 10 to the power of 6. Okay, another values for, sorry, another unit for pressure, sometimes they might give you in ATM, atmospheric pressure lah. That one you have to convert to Pascal. Constantnya diberi sepatutnya. Volume is 300 times 10 negative 6. Okay, berapa ni lagi?
1.38.
Okay, good. Darab 10 negative 23. And the temperature is 373.15. Kalau kamu kira ni, kamu dapat berapa sebenarnya? Cik kira.
9.33.
Okay, good. 9.33 ada darab 10 kuasa berapa ni?
22.
2, unit dia apa? Molecules.
Molecules.
Okay, good. Okay, very good. So this one is straightforward question. Okay, kalau ditanya macam ni dalam exam, okay lah. Memang senang. Okay, the next part is question number 7. When the pressure of an ideal gas is increased. Okay, ini ada dua situasi lagi 5.5 to 1.5. Its volume decrease from 2.5 to 0.5. Okay, if the initial root mean square velocity of the gas is V, okay, determine the final RMS velocity of the gas in terms of V. Final in terms of V. Okay, ini pun ada banyak cara. Okay, you can either use the method that I always use, yang sebelum ni saya selalu pakai, ataupun kamu boleh pakai yang cara saya tunjuk lah. Kalau yang method biasa saya pakai, saya akan buat dua equation tu, lepas tu saya cuba cari apa yang sama kan, saya factorkan, yang biasa saya buat. Okay, 1 and 2. Okay, but before that we take out the information first. Dia ada dua condition, condition 1 and condition 2. So dia kata increase from. So the 5.5 will be the initial one. That one will be my P1. Okay, kamu jangan salah tulis, baca betul-betul. Then my P2 would be 1.5 times 10 to the power of 5 Pascal. Its volume decrease from V1 sama dengan 2.5 times 10 negative 3. Okay, this one already in SI unit. To V2 equals to 0.5 times 10 negative 3 meter cube. If the initial root mean square, so itu adalah VRMS untuk 1 is equals to V. Determine the final VRMS in terms of V. So dia nak cek VRMS number 2. Okay. So which equation that you can relate PV dengan VRMS? Equation apa yang ada P dengan V dengan VRMS? Who can tell me? Farahia.
Yes, sir.
Equation apa yang kamu boleh kaitkan antara P, V dengan VRMS? Apa benda yang ada tiga-tiga benda ni? Ada?
Saya pun tak tahu.
Cuba tengok nota. Okay. Kita tanya Veronica. Equation apa yang ada ketiga-tiga benda ni?
Saya yang V dengan apa tadi sir?
VRMS.
VRMS. Saya pun tak sure lah ni sir.
Sure.
Saya rasa macam P
Okay,
mean
kita try
square
balik, okay?
sikit je sir.
Apa dia?
Yang PV 1/3 nm.
Yes, correct. Very good. Okay, jap.
Yang
Saya nak balik. Betul? Yang tadi yang kamu cakap tu betul. Saya cuma nak cari mana list equation yang saya listkan. Okay, ini list of equation yang diberi. Okay. So basically, kalau kamu dapat soalan macam ni, apa yang kamu kena buat, you refer back to the list of equation. Okay. Ni kamu cari apa yang ada P, V dengan VRMS. Paling senang kamu cari VRMS dulu lah. Yang ada VRMS dua ni je. Kan? So antara dua ni, mana yang ada P dengan V? Yang ni dah tak ada P dengan V. So you left with this one. Okay, so nak tak nak you have to use this one lah. So that you can relate PV dengan VRMS. So itu gunanya kamu keluarkan information. So that you can refer back to the formula sheet, then you can choose the formula. So I'm going to take this formula. Okay, very good. Tadi siapa yang cakap satu pasang buat? Okay, so basically you want to use this formula. PV equals to 1/3 pakai apa? NM VRMS. Betul ke? Saya dah lupa.
betul sir.
Ada square?
V cos square.
Kan? Okay.
V square.
Okay, so if I were to substitute the first information, first condition tu, so substitute value. Okay. So then I would have P1, V1, 1/3 nm, VRMS 1 square. Okay. So my P1 is 5.5 times 10 to the power of 4. My V1 will be 2.5 times 10 to the power of -3. And then I have 1/3 and M sebab dia adalah in the same, basically in the same container kan, the same gas, so maksudnya dia punya N dengan M tu tak berubah pun. And then VRMS 1 sama dengan V. Okay, so dia jadi V square. That one is for the first equation. Okay. Maybe saya letak ini. I'm gonna put it over here sebab saya nak jimbatkan space sikit. So if I were to substitute equation yang atas ni dengan P2 pula, then I will have P2 V2 equals to 1/3 and M doesn't change, V RMS 2 square. This is the value that you want to find, V RMS 2 square. Sorry, V RMS 2. The square tu nanti kamu kena hilangkan lah. So if you substitute P2 and V2, then you will have 1.5 times 10 to the power of 5, 0.5 times 10 to the power of negative 3, 1/3, and M VRMS 2 square. This is your second equation. Okay, again, macam mana kamu nak hilangkan N dengan M tu? Apa operation? Apa dia?
Tolak.
Apa? Bar je, saya dengar bar. Ini kan cakap apa? Tak dengar.
Tolak.
Tolak. Kalau tolak, dia tak hilang tau. Dia jadi tolak boleh kot. Boleh kot tolak, tapi biasa kita buat darab atau bahagi ataupun masukkan dia, gantikan. The easiest way, kalau kamu tengok, sebab dia memang kalau saya letak per kat sini, saya berpotong straight away. Yeah, so actually dia adalah you can divide lah. So if I divide equation 2 with equation 1, so then I will have yang dua tu kat atas, satu tu kat bawah. We can press the calculator first with 1.5 exponent 0.5 tu kan. Darab dengan 0.5 exponent negative 3. So I got here is 75. Okay, 75 tu yang saya kira yang ni sama tak dengan kamu? And then yang atas ni I got 137.5. Jadi saya terbalikkan kan, 2 bagi 1, so dekat bawah ni lah 137.5. Okay, and then I have, kamu check kan takut saya salah kira. Ni yang right hand side. Okay, so now you can cancel out 1/3 N dengan M, so you left with that one. Okay, rearrange. So 75 divided by 137.5, I got 0.54545. So VRMS yang kedua over V sama dengan, okay, kalau saya ambil square root kiri kanan, then that means yang square dia tu hilang lah. Sebelah kanan saya ada square root 0.545. So I got here 0.738 V. Okay, since dia dalam penyebut, so you don't have to write any unit. Leave it like that. Okay, understand tak? Can you follow? Can you guys follow this one?
Sir,
Boleh,
mana
sir.
hilang pergi V tu sir?
Mana?
Bawah.
Mana hilang apa?
V.
Oh,
Oh.
V ni. V ni saya buat naik atas. So dia jadi kat sini.
Oh ya. Okay.
Yang lain boleh ikut.
Okay, sir.
Boleh, sir.
Yeah.
Boleh sir.
So the key criteria, the key things on how to solve the problem is that actually you have to take out the information. Okay, kalau kamu take out information like this, then should be dah nak sampai lah. And then you have to choose the right formula. To choose the right formula, you basically have to compare with the formula sheet. Okay, kalau kamu kamu kena biasakan daripada sekarang, put the formula sheet on your side ataupun kamu tulis kat atas kertas, so that dah terbiasa nanti bila exam. And then once you did that, you just substitute the value, and then since dia nak cari dia nak cari VRMS, dia nak cari VRMS yang kedua ni, so you have to figure out how to cancel yang constant tu. Biasanya nak cancelkan constant, kamu bahagi. Okay, so once kamu dah bahagi, then you left with something like this lah, which is much more simpler form. Dan ini pun ada sedikit trick you have to do, is that you have to take the square root on both sides. Okay, barulah yang the square ni hilang. Then you get something like this. This is the final answer. Okay, so moving on to the next one, which is question number 8. Okay, question number 8 dia kata the RMS speed of hydrogen molecules at a particular temperature is 1330 ms-1. Okay, what is the RMS speed of the nitrogen molecules at the same temperature? Okay, so siapa ada idea on how to solve this one? Cik nak selesaikan? Okay, pertama sekali kita buat apa? Apa kita kena buat biar dapat soalan?
Keluarkan maklumat.
Yes, keluarkan maklumat. Very good. Okay, so again dia tak nampak clear sangat, tapi dia sebenarnya ada satu temperature tu ada satu speed. Lepas tu dia kata at the same speed berapa? Oh, dia sebenarnya adalah satu condition, tapi dia punya molar mass yang berbeza. Okay, now let's see. So kita keluarkan maklumat dulu. VRMS for hydrogen is equals to 1330 meter per second. Okay, at a specific temperature. Soalan dia VRMS untuk nitrogen. Sorry. Nitrogen N ke N2? N2 eh?
N2.
N2. Saya tak sure eh.
N2.
Okay, kalau saya salah nanti kamu betulkan lah sendiri. Saya rasa N2. So dia nak cari VRMS untuk nitrogen at the same temperature. Okay, both of these occurs at the T constant lah, because same temperature. Okay, again, kamu nak pakai equation mana?
So kalau V sama dengan punca kuasa 3kT per M.
Okay, boleh? Boleh? Okay, sekejap saya akan naik atas, kamu tutup mata jap sebab nanti dia pening. Saya cari equation tu. Okay.
Kami ketua kan?
Saya akan copy this one.
15 kan?
So formula untuk VRMS ada dua sebenarnya. Dua bentuk lah. Satu yang VRMS sama dengan something. Satu lagi yang PV tu. Okay. So now the first two equation, yang dua ni diberi dalam exam. This one is given in formula sheet. Yang ni tak diberi. So you can memorize this one if you want to. If you want But then most likely you have to use this tu lah. Tapi yang ni kalau kamu boleh hafal, kadang-kadang pakai ada certain years dia pakai. Okay, so kalau dia beri molar mass M kecil ke M besar?
M besar.
M besar. So M besar dekat equation here. So obviously you have to use this equation lah, 3RT over M. If you want to use this one, also can, but you have to do a little bit of conversion. Nanti dia dapat yang equation sebelah tu. So might as well we use 3RT over M. Very good. So for VRMS untuk hydrogen, so the idea is that you want to find the temperature first. Okay, once you found the temperature, then you can calculate for the nitrogen. So this is actually molecular mass for hydrogen, and this is the molecular mass for nitrogen. Okay. Okay, so it will be. Okay, so saya highlight yang kita akan pakai yang ni. So saya substitute sekejap kita tak terima kali. R sama dengan berapa? Betul ke?
Betul sir.
Betul So
8.31.
molecular 8.31. Okay, good. Molecular mass for hydrogen is 2 gram per mole. Okay, my question is, do I need to change to kilogram or not?
Perlu.
Belum, yes. Because any equation that has a constant like R ataupun K, you have to use SI unit. So maksudnya dekat sini, you have to use kilogram. And over here, you have to use kilogram per mole. Okay. Tapi yang ni untuk soalan ni specifically, katakan kamu terlupa, kamu akan terselamat. Sebab apa? Dia ibarat kamu perkan. Nanti mungkin kamu tak nampak, tapi dia sebenarnya macam itulah. Kalau kamu kebetulan dapat betul, kebetulan. Tapi sebenarnya you have to convert. Remember that. So this one will be 2 times 10 negative 3. 2 gram kan? Tukar per kilogram, 10 negative 3. Okay. Patut saya letak je RMS tu. Okay, saya letak lah. Semalam tu banyak kali. So I'm gonna substitute this one as well. And this one is 1330. So this one is for hydrogen. Okay, harapnya kamu faham aja. Then 1330, kamu nak cari definity tu. Kalau saya squarekan. Kamu punya calculator dah canggih kamu boleh tekan semua, dia akan keluar semua kan, tak ada masalah. So temperature kat sini dapat berapa ni? What is the value for temperature here? Berapa? Kamu lah katakan ni calculator canggih. Kamu boleh masuk square root tu sekali.
Tinggikan nilai dia.
Berapa?
141.909.
Okay.
Apa tu?
141. Betul? Point
Betul.
91. Is it correct?
Wait. 9.
Sama?
Boleh lah 91.
Boleh.
Sama.
Okay, good. That one is the temperature. So temperature is constant. So you can use the values for temperature. Now you can calculate for nitrogen. For nitrogen, the VRMS, I'll put the N2 here, is equals to, again, using the same formula, then I have 8.31, but now I already have the temperature, divided by, dia kata 28 gram per mole, so it will be 28 times 10 negative 3. Itu kira. Syazina, dapat apa? Syazina Atila. Syazina akan kira ke? Naila? Mana Naila? Naila ada?
Ada saya. Sekejap kaki saya.
Okay, good.
Tengok saya punya jawapan salah.
Tak apalah, kira yang ni. Kalau yang ni dapat apa? Macam mana kamu tahu salah?
Saya dapat.
Dapat apa? Dapat apa?
Saya dapat 355.4
Okay, good.
5
355.46. The unit will be, unit apa? Azmin, apa unit dia? Azmin, are you there? Okay, Azmin tak ada kot. Ada tak Azmin?
Yes sir.
Berapa, apa unit untuk VRMS?
Unit dia ada.
Okay, apa unit dia? Mungkin lagging sikit kat sini.
MS negatif 1.
Okay, good, very good. That's good. It will be MS
Unit
minus
dia
1. So dia samalah dengan speed.
Ha?
Betul lah? Okay,
Ah.
thank you. Okay, any question? Syazina to the left. Yang lain ada saran tak? For question number 8, kalau tak kita pergi ke question number 9.
Okay sir. No,
Alright.
Tak ada sir.
Okay, sir.
Now kita pergi ke question number 9. Determine the temperature at which RMS speed of helium in the molecules is 1.3 times greater than its RMS speed at the temperature of 310. Okay. Determine the temperature. Okay. So yang ni dia kata dia ada dua condition lah. So you have condition 1 and you have condition 2. Okay, dia kata dia suruh cari temperature T2, which RMS speed of the helium molecules is 1.3 greater than RMS speed at 310. So yang initial ataupun yang T1 ni is 310 Kelvin. Okay, dia kata dekat sini juga V RMS dia is equals to, katakanlah ini adalah yang pertama adalah equal to V. That means V RMS untuk 2 is equals to 1.3 V. You guys agree with this or not? Faham tak ini?
Agree. Faham sir.
Okay, good. So now, if using logic lah, T1 and T2, kamu rasa T2 tu lagi besar daripada T1 ataupun T1 lagi besar daripada T2? If you are looking at the velocity.
T1.
Mana lagi besar?
T2.
T2 nilai dia akan lagi besar lah. So logically you will expect that the values for T2 will be bigger than 310. That tu isi lah. What is the value? Maybe betul. Okay, now which formula that do you want to use? Formula mana nak pakai? Kalau kamu tengok yang before this, kita ada 3 formula tu kan. Kita paste it over here.
3RT/M.
Saya nak pakai yang mana? Yang pertama
yang
ke, kedua ke,
kedua.
ketiga?
Kedua.
Kedua tak kisah, mana-mana nak pakai boleh. Let's say you want to use the second one. Kita ikut je cakap. VRMS. If you are using this equation, we want to use this one. So for the first one, I will have VRMS1 equals to square root of 3RT1 over M. Okay. Dia still R dia constant, so R dia tak ada 1, 2 lah. M dia pun sama, so you don't have M1, M2, just leave it like that. Then for VRMS2, I will have square root of 3RT2 dengan M. Okay. So the only value that is changing yang ada 1 dengan 2 tu adalah VRMS dengan T saja. Okay, now I can substitute certain values. So katakan saya substitute. Substitute values. VRMS1 kita assume is equals to V. So I'm going to put V over there. Square root of 3RT. T2 adalah T1 310. Molar mass is M, so I'm going to leave it as M. And then over here I have VRMS2, which is 1.3 V. Okay, ini dah beli masukkan dia. 3R T2, kita nak cari T2 tu M. So this would be my first equation and this would be my second equation. Okay, again, I'm going to ask, how do you want to cancel out the R dengan M tu? Macam mana nak cancel out? Apa dia?
Divide.
Okay, kamu nak buat mana divide mana? Apa dia? Tak dengar, sorry. 2/1. Okay, 2 divide by 1. Kita tak kisah, dia mana-mana pun boleh. So kita buat, kita ikut. If 2 divided by 1, okay, so I will have belah kiri tu 1.3 V over V equals to, belah kanan pula, 3RT2 over M square root 3R310 over M. Okay. So apa yang kamu boleh cancel? You can cancel out R, M, and then you can cancel out the V. Okay, straight away kamu left with only variables there, which is T2. T2 yang kita nak cari. So I think you can solve this one lah. Senang ya. So Okay, now the tricky, 3 tu boleh potong juga, sorry. Now the tricky part sebab dia ada square root tu. Okay, tapi square root dia, kalau kamu ada contohnya 3RT2 over M ni kan, square root besar ni, yang ini sebenarnya sama dengan square root of 3, square root of R, square root of T2 dengan square root of M. Dia sama. The advantage of square root is that you can separate it like that. Simple je sebenarnya. Cuma student bila nampak square root dia takut. So, don't worry. So, kalau saya rewrite, I have 1.3 on my left hand side and then I have square root of T2 over square root of 310. Okay, you can either calculate separately ataupun you can do it right like that, like this, sorry. T2 over 310. Sama je. Both of this is correct and both of this you can write like that. So you can take the square on both sides and then you multiply with 310, you should get the answer. So 1.3 square multiply with 310, you should get berapa dapat ni? Berapa dapat? Amir. Afazal nak cakap apa?
Yes, sir.
Amir, berapa Amir dapat?
523.9.
Okay, very good. 5 to 3.9. Unit dia apa?
Unit dia Kelvin.
Okay, good. Sebab dia SI unit So we've been dealing with the SI unit, so final answer will be SI unit as well. Okay, very good. Okay, ada soalan? Okay, before this kamu dapat ke tidak?
Tak dapat.
Okay, so kamu keluarkan macam ni tak?
Tapi
Tapi lepas-
tak tahu pakai formula apa.
So itulah kalau kamu keluarkan, kamu cuba relatekan. Relatekan dia punya equation tu. Okay. Tak apa, nanti dah cukup praktis kamu nampak kot. Saya dah selalu buat, okay dah kot. Okay, next question, which is question number 10. Question number 10, dia kata the RMS speed of the atoms of monoatomic gas at a temperature of 20 Celsius is 603. Okay. Find the mass of an atom of the gas. Okay, I think we might have to use the VRMS equation lagi. Okay. Okay, VRMS ada dua, satu equation yang macam ni, satu lagi yang bentuk yang 1/3 tadi ada. Itu PV sama dengan 1/3 tu. Ini lah. So, question A, kamu keluarkan dulu information. Temperature is equals to 20 Celsius. VRMS is equals to 603. And then apa lagi dikasih? Natural mass. Okay, which equation that you want to use? 1, 2, 3.
1.
Sebab ini je yang ada mass, so you want to use this one lah because you want to find the mass. Senang, tidak ada masalah kot. So to solve this one, I can substitute all the values. 603 equals to square root of, kamu jangan tertukar nilai K dengan R. K here would be 1.38 times 10 negative 23. The temperature you have to change to Kelvin, which is berubah berapa ni? Equals to 273.15 plus 20, we get 293.15 Kelvin. Masukkan dalam equation. And then the mass is the one that you want to find. So you can take square on both sides. Kira-kira dapat apa ni? Kita dapat lah. Ni dapat tak?
3.34 darab 10 negatif 23.
Berapa dapat?
3.34.
3.34 times 10 negative.
23.
Okay. Berapa? Tak dengar, sorry. Negatif apa?
23 sir.
23.
26.
Kan? Saya dapat 26. Saya
26.
Benar,
Salah
okay.
sebut.
Okay. Ngantuk tu. Okay. Ada yang tak dapat tak for this one? I think this one senang. Okay, question B. What is the root mean square of the oxygen molecules at 300 Kelvin? Nak pakai equation mana?
Root mean square lah.
Okay. 1, 2 ke 3?
Dua sir.
Kenapa pakai 2?
So dia ada M besar.
Yes, sebab dia beri M besar. Molar mass of oxygen is 32. So to calculate that one, you can use VRMS equals to square root of 3RT. So 8.31. Okay, the temperature is already in Kelvin, so 300 divided by 32. Nak tukar tak dalam kilogram? Okay.
Tukar sir.
Tukar. Okay.
Tukar sir.
Good. Okay, tukar ke SI unit kilogram. 3. Apa yang dapat ni? How much you get? You just get the same answer with me?
482.4. Sama.
Sama Okay, good. Okay.
Sama sir.
Now we moving on to the next question lah, question 11. Tadi question 10 tu menarik lah. Okay, state the 3 assumption of the kinetic theory of gases. Okay, this one we already discussed. Okay, yang dia kata dia bergerak randomly and haphazardly. Intermolecular forces between molecules are negligible. Sorry, the time during collision is negligible compared to the time between collision. Okay, those kind of thing lah. You can decide any 3 assumption. Itu I'm not going to discuss that one, but I'm going to discuss question B ni. Okay, question B ni dia pernah tanya dalam PSPM once, sekali dia tanya. To use the kinetic theory of gases to explain quantitatively how a gas pressure acts on the wall of the container. So if you have a container like this, kita katakan, and let's say this container is filled with hydrogen. Hydrogen ada 2 sepadan balik. Saya tukar helium. Okay, let's say it is filled with helium. Saya malah nak lukis. Okay, it's filled with helium atoms. Okay, dalamnya ada banyak lah. So dia kata use the kinetic theory of gases to explain kenapa ada pressure. So obviously kalau container ni penuh dengan gas, you expect to have a high pressure inside the container. So pendapat kamu lah, kamu rasa kenapa? Macam mana boleh ada pressure tu? Sebab apa? Nadira, what do you think? Nadira ada? Aminah?
Dia slow kot sir ke?
Apa dia?
Slow kot internet dia.
Fazana cakap apa? Dia breaking tu. Macam
Baby slow kot line dia kat sana.
okay. Tak apalah, kita tanya Veronica. Veronica rasa kenapa?
Langgar dinding kan.
Okay, betul. Exactly. Okay, tapi kalau kita nak cerita, we have to cerita sedikit lah. Okay, so first of all, you know that this gas contains of atoms or molecules. Okay, so any gas consists ataupun contain atoms or molecules. Ini assumption yang kita buat. Ini pun boleh letak dalam jawapan A, molecules. Okay. And then these atoms or molecules will move randomly or haphazardly. Okay. So if it moves randomly, you expect it to collide with each other, and eventually it will collide with the wall as well. Okay. If you collide with wall, you will expect to have change in direction of velocity. Kalau dia datang kan, and then they rebound, so that means there's a change in velocity. Walaupun dia punya speed sama, the velocity yang ada direction tu mesti berubah. So because of that, you will have delta P. Okay, this is a change of momentum due to change in velocity. If you have delta P, you will have force. Okay, and this force that is acting on the wall will produce a pressure. Faham ke tidak? Ni ringkasan lah cerita dia, mungkin kamu boleh tengok details lah. This one, yang point yang dia nak sebenarnya adalah bila dia ada collision with the wall, dia akan produce a change in momentum, and change in momentum will result in pressure. Salah je pressure. Okay, any question? Tadi ada orang kat tangan.
Change with momentum. Apa sebenarnya?
Terdengar? Sorry. Bila kamu ada perubahan momentum, maksudnya dia akan produce force. Force tu acting on the wall lah. Maksud saya, bila dia berlanggar dekat sini kan, dia akan ada perubahan V. So bila ada perubahan V, dia akan produce perubahan P. Perubahan P tu yang menyebabkan ada force. Force tu yang punca pada pressure.
Oh, okay. Faham.
Okay. Alright, good. Dah okey dah soal Fazana. Tadi dia breaking. Ini dah okey dah. Okay, so that one is for question 11. Ada soalan tak question 11?
Tak ada, sir.
Okay, now moving on to the next question. The tank has a volume of 0.7 meter cube. It contains 2.5 moles helium gas. Okay, temperature dia adalah 10. So, tak tahu pakai ke tak, saya convert terus. So, 273 plus 10, 283 lah, 0.15. Okay, behave like ideal gas. Calculate the total translational kinetic energy of the molecules of the gas. So, kamu rasa dia nak cari translational kinetic energy untuk satu molekul ke semua molekul? Untuk soalan A tu. Sebab apa? Apa keyword yang kamu kata dia semua?
Total.
Semua.
Yes. So dia nak total translational kinetic energy. It means that the total KTR. So total KTR. KTR ni kalau dia untuk satu molecules, then you can use formula 3/2 KT. Tapi sebab kamu bukannya nak cari satu, kamu nak cari banyak, so kamu boleh pakai N, darat dengan N lah, darat dengan numbers of molecules. Okay, so if you want to use this formula, that means you have to find N dulu. Actually N ni senang je, kamu ada numbers of mole, multiply with Avogadro's number 6.023 times 10 to the power of 23, and you can substitute inside here. Okay, you will get total translational kinetic energy. Okay, alternatively, you can use another formula which is equals to nRT. Dia partner dia tu lah. Kalau KT, dia N besar. Kalau RT, N kecil. Sebab dia beri N kecil, so might as well we use this formula. Okay, mana-mana boleh, doesn't matter. So 2.5 3/2. Saya tak pasti formula ni diberi ke tak. Yang KT tu memang beri. Kita check. 283.15. So the total translational kinetic energy will be 2.5 multiplied 3/2 multiplied 8.31 multiplied 283.15. I got here is 8.82 times 10 to the power of 3. Okay, Fatin Akilah, unit dia apa ni? Thank you lah. Tanya Azrina lah. Azrina, unit dia apa? Azrina tak
Joule,
ada?
sir.
Apa? Joule, yeah.
Joule.
Okay, thank you. Okay, that was for question A. Question B pula. Jadi the average molecular kinetic energy. So dia tak kata total kan? So dia nak satu ke banyak?
Mana tadi siap?
Nak
Ah,
semua.
Soalan B tu, the average molecular kinetic energy. So maksudnya dia nak untuk satu molekul ataupun kesemua molekul.
Semua kan?
Semua.
Tak, dia tak cakap semua.
Maksudnya satu kan?
Tak satu. Tapi dia nak kinetic energy Okay. Saya try lukiskan gambar dia. Okay, kamu bayangkan kamu ada tank. Container that consists of helium. Dikatakan dalam container ni ada 3 ketul helium. So by logic, kalau kita nak cari yang untuk semua KTR tadi, kamu kena darab dengan 3 lah. Bila kamu dah dapat untuk satu molekul, kamu darab 3. Okay, tapi soalan nombor 2 ni kata average molecular kinetic energy, dia hanya nak untuk satu je. Untuk satu helium ni berapa molecular kinetic energy. But you have to remember, for every molecule, they consist of 2 types of kinetic energy. One is KTR, satu lagi adalah K rotational. So dekat helium ni ada tak rotational? So K ni sebenarnya adalah KTR campur dengan K rotational. So my question is, do you think that this helium has rotational kinetic energy? Ada ke tak ada? Teka je, salah tak apa?
Tak ada sir.
Kenapa tak ada?
Sebab dia monoatomic.
Yes, exactly. Sebab dia monoatomic, dia tak boleh nak berputar dengan yang dia punya partner lah. So dia seorang dia, so tak ada. So K rotational ni tak ada. So for this one, dia punya K tu actually formula dia akan sama dengan kinetic translational kinetic energy untuk yang satu lah. Basically tak perlu darab dengan N. Okay, alternatively you can refer to the formula sheet. Then you can use this formula. F/2 KT. Okay, but since dia adalah monoatomic, F is equals to 3. Okay, so kalau nak mean kinetic energy, average ke mean ke, itu biasanya dia nak yang K kanan ni untuk kinetic energy. Dia tak cakap specifically untuk translational, maksud dia nak kedua-dua lah, rotational dengan translational. Cuma yang ni dia tak ada rotational, so it becomes 3/2 KT. Okay, sebenarnya kalau kamu tengok formula sheet, you can use this formula straight away. Yang atas-atas kamu tak perlu fikir pun tak apalah. K is equals to 1.38 times 10 negative 23 multiply with the temperature, which is berapa temperature ni? 283. Okay, berapa dapat K ni?
-5.86
Okay,
darab
5.86.
10 negatif 21.
Okay, very good. Okay, very good. Okay, so this is how you answer lah. So tu dia cakap, for the last subtopic tu, kalau kamu faham, sebenarnya senang je kamu nak bezakan soalan tu nak translational ke, nak semua kinetic energy ke, untuk satu ketul ke, untuk semua ketul. Okay, so maksudnya yang kamu kira, yang kamu kira ni untuk satu molecules. Tapi dia hanya consider KTR sebab kalau monoatomic, K rotational tu tak ada. Okay. So moving on to the next one, question number 13. A balloon of a diameter 20 cm was filled with a helium gas at a 30 Celsius at 1 atm. How many atoms of helium gas are filled inside the balloon? Dia dikasih diameter, so I assume that the balloon is filled. Even though we know in real world it wouldn't look like a sphere lah, seperti dia cakap ya. So kalau volume untuk sphere, you guys remember the formula tak? Ada 4/3. Maksud apa? Ada pi.
Pi.
So ada apa? R kuasa berapa?
3.
Okay, very good. Okay. So it is 4/3 pi r cube. Okay. Saya dulu saya selalu confuse between surface area dengan volume tu. Tapi sebenarnya beza dia dekat cube dengan square tu. Kalau cube tu untuk volume. R cube kan, so volume. So akan calculate the volume straight away. Since yang dikasih tu diameter 20 cm, so radius divide by 2 is 10 cm. So akan calculate 4/3 pi 0.1, I change to meter cube. Okay, volume dia dapat berapa? Come on guys, berapa volume dia?
4.19 times
Okay,
10 power negative 3.
4.19 times 10 negative 3. Unit dia dalam meter cube lah. We change the meter already. So senang. Okay. Okay. And then dia ada kata yang pressure is at 1 atm. Okay, 1 atm ni sepatutnya dia berilah dalam exam. Nombor dia kadang vary sikit. 1.01 times 10 to the power of 5. Dia kadang 1.015. Kadang 1.011. 1.10, sorry. Tinggal. Kau nak pakai berapa ni nilai dia? Dalam exam dia akan berilah. Okay, let's say we use this one lah. 1.101. Okay, Pascal. Nanti kalau dia exam, dia kasih list of constant kan, dia akan tulis macam ni. 1 atm per dot berapa nilai dia with Pascal. So you just have to use that value. Kalau dia kasih 3 tempat pengolahan, use 3. Kalau dia kasih 4, use 4. Okay, follow the given constant. Temperature at 30 degrees Celsius, I change to Kelvin, 303.15 Kelvin. Okay, how do I find numbers of atoms? Sama ada PV dengan T, kamu boleh kira tak?
PV equal to nRT.
Yes. Okay, if you want to use PV equals to nRT, that means you have to find N dulu kan. Once you got the N, you can convert into dengan atoms kan. So you can convert to molecules or atom by multiplying with the Avogadro's number. Alternatively, you can straight away use NKT and NKT lah. Yeah. So my N is equals to P darab V. V is 4.19 times 10 negative 3 over KT berapa dapat ni? Farahia, berapa dapat?
Sekejap Ustaz nak kira.
Okay, kira.
Saya dapat
Hmm.
1.10
Okay,
darab 10 kuasa 23.
okay, very good. So this one is numbers of atom. So if you use the different values for one ATM kan macam 1.11 ke apa ke, then you might have a slightly different answer. So it's okay. That one is for question 1. Question 2, calculate the average kinetic energy of the helium atoms. Okay, yang ni nak satu ke semua?
Semua atoms kan?
Itu yang atom S tu buat confuse. Tapi sebenarnya tak ada.
Satu je.
Dia nak satu. Sebab dia tak ada cakap total. Kalau dia kata total, yes. Okay. Saya pun awal-awal tadi saya confuse juga. Tapi bila saya baca balik, okay. Average kinetic energy. Dia nak translational ke dia nak gabungan translational dengan rotation? Maksud saya, dia nak K yang ni ke ataupun KTR? Which one? Yang ni ke? Oops. KTR ke
KTR.
Okay. Kalau KTR, dia memang akan sebut translational kinetic energy. Kalau dia tak sebut translational je, we assume that they want to find KTR tambah dengan K rotational. So, dia gas apa kan? Helium. Okay, so helium.
Atom.
Mono ke di?
Die.
Ya ke?
Kan.
Helium.
H2
H2 hydrogen.
monoatom.
Oh,
Yes, so it will be mono. Okay, good, very good. Okay, at least kamu cuba lah. Okay, good, very good. So kalau mono, so basically kalau kita pakai formula ni sebenarnya dia dah, kamu boleh pakai ni straight away. Okay, dia nak apa average kinetic energy of the helium atom. Temperature dia. Okay, so temperature dia you can use any formula lah. KT. So kalau for mono, F dia berapa? F equals to 3. So your equation now becomes 3/2 multiplied with 1.38 that's 10 negative 23. Temperature is 303.15. Okay, berapa ni dapat? Cik kira. Siti Aminah, berapa dapat? Dah ada belum? Tapi kamu tak panggil Siti Aminah, kamu panggil apa? Eliana.
Apa sah?
Berapa jawapan dapat?
6.27.
Okay, good. So you get 6.27 times 10 negative
21.
21 joule. Okay, very good. Thank you. So that's it for part A. Ada part B pula. Vessel contains, okay, maybe saya turun soalan ni kot. Okay, yang A tu dah settle. B pula. A vessel contains N molecule of an ideal monoatomic gas at a pressure P and temperature T. Write an expression for the total kinetic energy of the molecule in terms of N, T, and K. Total kinetic energy. Dia nak KTR ke K kiri kanan? K arrow tu. Oops. Ke KTR. Ke bukan kedua-duanya? Nak apa sebenarnya?
Dua-dua kan?
Betul. So, dia nak total. Kalau total tu maksudnya nak satu ke semua?
Semua.
Okay, so dia kalau untuk for a molecule, okay, untuk satu ketul, K dia sama dengan F/2 KT. Okay. Kenapa kita pakai F/2? Sebab ini dia tak ada cakap translational. Kalau translational, straight away kamu pakai 3/2 lah. Jadi sekarang dia kata monoatomic. So, for mono, F sama dengan 3. Okay. Which is 3/2 KT. Remember this one for one molecules. Okay. For total, basically you have to multiply with numbers of molecules. Multiply by N. Benda yang sama, darab dengan N, you should get untuk kesemuanya. Faham ke tidak ini?
Kenapa answer?
Kenapa N? Sebab maksud saya kan, contohnya kita ada container. Oops. Katakan dalam ni ada 5 ketul monoatomik. Banyak sangat pula 5, 2 je lah. Katakan dia ada 2. So setiap satu ni, value dia is this one. Kinetic energy dia untuk satu tu adalah 3/2 KT. Tapi dia ada 2. So darab dengan 2. So 2 ni sebenarnya numbers of molecules ataupun numbers of atom lah in this case. Faham tak?
Faham. And okay.
Itu. Okay. Ada soalan dah. Itu je. Okay. The next one is question number 14. State the number of degree for freedom for monoatomic, diatomic and polyatomic. Ini senang lah. So maybe saya boleh buat macam table. Monoatomic. This one is the type. Diatomic. Polyatomic. Okay, and you want to find the degrees of freedom. F, so will be berapa ni?
3,
3, diatomic.
5,
Poly.
6.
Okay, but remember all of this is actually occurs at temperature around 300 Kelvin. Okay, kalau more, especially for polyatomic, then they will give you a new degrees of freedom. Sebab dia kasih kami ikut je lah. Okay. Ikut. Okay, B. Calculate the mean kinetic energy of a molecules of ozone, O3, at a temperature of 27. Kalau mean kinetic energy, maksudnya dia nak translational ke yang K kiri kanan tu? KTR ke K? Mana satu?
K.
K.
K tu So kalau kamu nak cari K kiri kanan tu, dia sama ada nak cari total ataupun seketul. Yang ni total ke seketul?
Total.
Ya, cuba cakap. Seketul So dia kata a molecule. Okay, so baca sama betul lah. It's okay, don't worry. Cuba kena careful sikit lah. So this would be F/2 KT. Beza dia kalau nak semua tu kamu kena darab dengan n numbers of molecules. F dia berapa ni? Dia
5.
poly ke? Ya ke?
6 atom.
Dia mono ke di ke poly?
Oh poli. Oh 3
Nanti kalau ada O3
3.
dia adalah 3 lah. For poly, kalau lebih daripada 2 je dia pakai 6. Tak kisah berapa. And F is equals to 6. So K kita sama dengan 6/2 1.38 times 10 to the power of negative 23. Temperature is at 27. So 27 you have to add with 273. So you will see that this one is actually very close to 300 Kelvin. So that's why the value kita pakai K, F dia 6 tu. Nampak apa ni? Kelvin, how much you get?
Wait a sir.
Okay, it's okay.
Sir, 1.24
1.24.
times 10 power negative 20.
Okay, good. So the unit will be in joule. Okay, very good. Thank you, David. Okay, that one's for question number 14. Any question?
No sir.
No sir.
No, sir.
Okay, now for the last question. Kita ada 2 moles of an ideal monoatomic gas. Monoatomic F dia berapa? Kita buat terus.
FJ3.
Okay, kalau dia sudah tanya lah. Kalau dia tak tanya, don't bother lah. Okay, 2 moles. So maksudnya N dia sama dengan 2. Closed container constant volume. Heated until its pressure is double. Okay. So kalau kita, dia ada 2 condition So condition number 1 dan condition number 2. Okay. Basically you have P1. Katakan P1 sama dengan P. Maksudnya P2 sama dengan berapa? Kalau dia kata pressure is double.
2P1.
2P.
2P. Okay. So kita dah kata yang P1 to P kan. So dia 2P lah. If the final temperature of the gas is 750, so that one is your T2. Calculate the initial temperature. T1 sama dengan berapa? Okay. Now, kalau V constant, ini sebenarnya adalah apa? Boyce ke, Charles ke, Gay Z?
Gay Z.
Yes. So this one is represent Gay Z. So if you guys still remember, kita ada triangle tu. PV dengan T. Kalau V is constant, basically kamu akan ignore this one lah. So you left with PT equals to PT. So P over T equals to P over T. So kalau yang ni 1, this one will be 2. Senang je actually. Yang ni biasa dikasih sampai 3 condition. So you have to do it separately so that you don't mix things up lah. So kamu kena buat step by step kalau dikasih 3. So P 2P over 750. Then you want to find the T1. Cancel out the P. T1 apa ni? 3 7.5. Berapa? 750 divided by 2. Betul kan? Did you get the same
Betul,
answer
sir.
with me? Okay, good. Okay, this one is for the first part. Senang je. A. Question B, dia kata the change of the internal energy of the gas. Okay, so this is the question for internal energy. Internal energy formula dia apa? Okay, simbol dia apa dulu? internal energy dia adalah pakai simbol apa ni? U sama dengan F/2 NKT. Betul tak? Kalau nak total lah. Tapi dia bukan nak total, dia kata nak change of the internal energy of the gas. Okay. So saya padam sikit. Okay. So therefore, for change of internal energy, so delta U lah, U2 minus U1. Okay, this one is a monoatomic. So delta U dia sama dengan, itu tak monoatomic. Monoatomic, so it will be 3/2. K itu tak berubah. So T2 minus 3/2 K T1. Sekejap saya akan baca balik. Saya tidak total Okay, kalau untuk per molekul, biasanya dia cari itu ada yang K kiri kanan tu. K kiri kanan tu biasanya kita pakai simbol K kiri kanan lah. Tu nama dia biasanya mean kinetic energy. Kalau U tu biasanya dia consider semua, walaupun dia tak cakap directly. Tapi biasanya dia akan cakap directly lah. So dia tak cakap tu yang saya tak perasan. Okay, U ni sebenarnya ada dua formula. So you can use NKT ataupun alternatively you can use N F/2. Tapi kalau kamu pakai N kecil tu, you have to use RT. Okay. I'm going to use the second part, second equation too, because they give you the numbers of mole, which is 2. Oops. We erase this one. So it will be N F, so 3/2 R T2 minus N 3/2 R T1. So I can factorize the NR dengan 3/2 tu sebab dia adalah sama (8.31) T2 minus T1, which is 750, minus 375, which is 375. Then your delta U, kita dapat berapa ni? 3 multiplied by 8.31 multiplied by 375. 9.35 times 10 to the power of 3.